Welcome to my channel, The Proper Guidance. Here we are today discuss about chapter number 4, Q of class 12 computer science. Previously we have done stack. Today we will discuss about Q. And in this chapter we have to discuss about introduction to Q, operations on Q, implementation of Q using Python, introduction to DEQUEue, implementation of DEQUEue using Python. Okay, so let's start. First, introduction to Q. In the previous chapter, we learned about a data structure called stack, which works on last in, first out, LIFO principle, right? In this chapter, we will learn about another data structure called Q, which works on first in, first out, that is FIFO principle. Okay, so this is the principle used in Q. First in, first out. Q is an ordered linear list of elements having different ends for adding and removing elements in it. Okay, so here is a queue of people at a bank, and the name implies that we have to stand in a queue in a bank, in the cashier or any counter, one by one, and one who is in front of the queue, after completion of his task, he is removed from the line and next one get the chances, right? And this is known as first in, first out, and this concept of queue is also used in data structure, and that thing we will learn in this chapter. Okay, so examples of queue in our everyday life include students standing in a queue for morning assembly, customers forming a queue at the cash counter in a bank, vehicles at fuel pumps, and so on in normal life. Now, first in, first out. Queue follows the principle of first in, first out. Since the element entering first in the queue will be the first one to come out of it, thus, the element that has been longest in the queue will be removed first. Okay, it is also known as first come, first served, FCFS approach. Same thing, first in, first out and first come, first served. This is the actual approach of queue. Queue is an arrangement in which new objects or items always get added at one end, usually called the rear. The end in which it is added is known as rear, and objects or items always get removed from the other end, usually called the front of the queue. So, rear is also known as tail and front as head of a queue. These are the very basic definitions of first in, first out approach, that is first come, first served approach, and which is used in queue. Okay, and now applications of queue. The concept of queue has many applications in real life. There is nothing to discuss about this, right? A train ticket and all those things, customer services, single lane, one-way road, in all those things, first in, first out approach is applicable. Now we will discuss about some examples of application used queue in the computer science. Okay, so notice in this particular point number B, suppose there is a web server hosting a website, declare results. This server can handle a maximum of 50 concurrent requests to view results. Okay, got the point? Here is a web server hosting a website to declare result of any examination, and it can handle maximum of 50 concurrent requests to view results. So, to serve thousands of user requests, a queue would be the most appropriate data structure to use, because when you request the first, you will be served first. Okay, this concept is used here. And then some operating systems are required to handle multiple tasks called jobs seeking to use processor. Okay, but we know that a processor can handle only one task at a time. Therefore, in a multitasking operating system, jobs are lined up, that is queued, and then given access to the processor according to some order. the simplest way is to give access to the processor on a FIFO basis, that is first in first out basis, that is according to the order in which the jobs arrive with the request for the processor. Okay. When we send print commands from multiple files from the same computer or from different computers using a shared printer, the operating system puts this print request in a queue and sends them to the printer one by one on a FIFO basis. Okay. So, these points to be noted, actually these are the examples of application of queue in computer science. Clear? Next, operations on queue. Okay, previously in the previous chapter we have already learned about some operations on stack. Here we will learn about operations on queue. Following the FIFO approach, data structure queue supports the following operations. First one NQUEue and the second one DEQUEue. Okay, so what is NQUEue? NQUEue is used to insert a new element to the queue at the rear point. The point where a new element is inserted, that point is known as rear. We can insert elements in the queue till there is space in the queue for adding more elements. Clear? Inserting elements beyond capacity of the queue will result in an exception known as overflow. Okay, and we also get this term overflow in the previous chapter in stack also. When there is no space in the stack and we are willing to input, take some input or insert new elements in the stack, the same exception also results there, and that is known as overflow. Same thing is also here for queue, and the name is different. In that stack section we insert some new element, and that was known as push operation, and same thing, same concept is followed in queue also, but the name is different. Here to take some input or inserting a new element is known as NQUEue, and when we are inserting some new elements one by one and there is no space to take some input, new input, again we are inserting something. In that condition, inserting elements beyond capacity of the queue will result in an exception known as overflow. Okay, very simple. And then DEQUEue. DEQUEue is to remove one element. Just opposite to NQUEue is known as DEQUEue. The name also implies that to remove. One is to insert and another is to remove one element at a time from the front of the queue. Clear? Front of the queue. We can delete elements from a queue until it is empty. Okay, we can delete elements from a queue until it is empty. Trying to delete an element from an empty queue will result in an exception known as underflow. Same concept was in stack also, and in that particular section we are also familiar with the operation pop, right, for stack, and equivalent in queue, this is DEQUEue, to remove some element at a time from the point of the queue. And when there is no element in the queue and again you are trying to delete something, it will result in exception and known as underflow. Okay, so very simple thing. To perform NQUEue and DEQUEue efficiently on a queue, following operations are required. So we often use these operations to use efficiently NQUEue and DEQUEue for a queue. That is, first one is empty. Is empty is used to check whether the queue has any element or not, so as to avoid underflow and exception. Okay, whether it is empty or not, we will check. The name implies it is checked whether the queue is empty or not. Okay, and we'll performing DEQUEue operation also. And next one, pick. Pick is used to view elements at the front of the queue without removing it from the queue. Pick is just to view elements at the front of the queue, not to remove. If you want to remove, you have to use that particular DEQUEue, and this is just to view elements at the front of the queue without removing what? Without removing it from the queue. This is pick. And the next one is full. Is full is used to check whether any more elements can be added to the queue or not, to avoid overflow condition. Okay, so while performing NQUEue operation, so 3 operations we are getting here, that is empty, pick, and is full. Now, figure 4.3 shows the various stages of a simple queue containing alphabets. In the figure, front of the queue is on the left and the rear on the right. Front of the queue is from left and rear. Now see, operation performed NQZ. When we are enqueuing something, that is inserting a new element in something, status of queue from after operation, that is from F to this one Z, and rear point, and then again front point. Okay, and NQX, again there is rear point, one line is there, I am highlighting this thing, front of the queue is on the left and rear on the right, and rear point means it is the point where you are inserting some elements from the right hand side and it will removed from the left hand side, that is this one F. Okay, so NQX, X is here on the right hand side, NQC again in the right hand side, DEQUEue, when we applying DEQUEue, we are dequeuing what? Dequeuing from the front side, F, that is Z is dequeued here, NQV again in the right hand side, DEQUEue means the leftmost term will be dequeued, removed from that one particular side, that is a X here, so CV and R, and DEQUEue again, and C is removed here. Various stages of stack operations, and you can't say it stack operation, actually this is queue operation. Okay, various stages of queue operations, please check it. Okay, next, implementation of queue using Python. There are many ways in which queues can be implemented in a computer program. One way is using the list data type in Python. For creating a queue structure in the program, following functions need to be defined. Let's create a queue named myQueue. We can create it by assigning an empty list, myQueue equals to list, a function enqueue to insert a new element, that is def enqueue myQueue element, myQueue.append. The append function is used here to append some new value up to that particular queue. And we don't need to implement is full, as Python, being a dynamic language, does not ask for the creation of a list having fixed size. Okay, hence we will never encounter a situation when the queue is full. A function is empty to check if the queue has an element or not. This can be done by checking the length of the queue. The function has a parameter, name of the queue, and returns true if the queue is empty, false, or these things. This is the code snippet. Please go through. A function DEQUEue to delete an element from this one. This is the particular section to DEQUEue. This is actually the pop function. Return this and DEQUEue. Okay, and now the pop function with index 0 will delete the element from the beginning of the list, hence from the front of the queue. A function size to get the number of elements in the queue. We can use len function of Python's list to find the number of elements in the queue. The function has one parameter, name of the queue, and returns the number of elements in the queue. This one. Okay, a function pick to check what? Check where is it, but not to delete, just to simply read. The function will just to read, not to delete the element at the front end of the queue. For this, we can read the element at index 0 of the queue. The function has one parameter, name of the queue, and returns the value of element at front if queue is not empty. Note otherwise this thing. Okay, so let us consider the example of a queue that people from while waiting at a bank cash counter. Please go through. This is very simple text. We please go through, and here is a program, and a program code snippet is here. myQueue list, each person to be assigned as P1, P2, P3. Now element, input entered person's code to enter in a queue. NQUEue myQueue element, one by one element will be inputted here. Element input this thing, again NQUEue myQueue element. Okay, again print removed from the queue. When we are removed from the queue, person removed from the queue is DEQUEue myQueue. This is for removing. Print number of people in the queue is size. This is size method is used. and element input entered person's code to enter queue, my queue element again. Element input taking input and output just like this. Please go through, and output is considered here. You please go through the concept of this queue, enqueuing this. Now, introduction to DEQUEue. DEQUEue pronounced Deque. This is actually this is pronunciation as a Deque, but in simple form we call it DEQUEue. DEQUEue is different thing. And now see here, Deque. Deque is an arrangement in which addition and removal of element can happen from any end, that is from head or front or tail or rear. This data structure does not apply any restriction on the side from which addition and removal of elements should happen. So this is a very important concept followed in Python for queue. Okay, no particular end to remove or to remove thing, removal of in which addition removal of elements arrangement is managed here. And so it is also known as double-ended queue, that is Deque. Double-ended queue, that is Deque, because it permits insertion, deletion operations from any end. You can do it. Insertion push operation and deletion pop operation. Insertion you can do it from here also, and this is rear point, this is front point, but this is not the headache. Basic Deque structure displaying head and tail implementation stack or queue. Okay, applications of Deque. What are the application of Deque? At a train ticket purchasing counter, a normal queue of people is formed for purchasing a ticket. A person at the counter purchased the ticket and left the counter. After a while, they return back to the counter to ask something. As they have already purchased a ticket, they may have the privilege to join the queue from the front. Okay, so this is the concept of Deque. Another example is here. Vehicles in a highway toll task booth are served following the principle of queue. There are multiple queues if there are parallel booths at the toll gate. In case all vehicles of a booth are served, then vehicles from the other booths are asked to form a queue in front of the vacant booth, right? So vehicles at the end of those queues will live removed from the end from where queue was joined to current booth and join queue at the vacant booth. Following are some examples where data structure Deque may be applied in computer science. This is the important point. Please go through. To maintain browser history. To maintain browser history URL, usually a stack is used because once a tab is closed and if you press Ctrl+Shift+T, the most recently closed URL is opened first, right? As the number of URLs which can be stored in history fixed. So when this list of URLs becomes large, URLs from the end of the list gets deleted. Same happens for providing the do and undo option in any text editor also. Okay, to check whether a given string is palindrome or not. Process string left to right character wise and insert it in a Deque from tail or rear like a normal queue. Once the entire string is processed, we will take out a character from both the ends and match them till there is no character left or only one character left in Deque. In either case, string is palindrome. Clear? Now, what are the operations on Deque? This is very important. Insert front. The name implies is used to insert a new element at the front of the queue of the Deque. Insert rear. This operation is the name imply also insert a new element at the rear of the Deque. Deletion front. This operation is the same as normal queue, that is to remove an element from the front of the Deque. Okay. And deletion rear, this operation is used to remove one element at a time from the rear of the Deque. Okay, to perform above operations efficiently on a Deque, we will need all supporting operations used in normal Deque, is empty, pick, cite, all these things. And here is also an algorithm. Let's understand how these operations work, or checking whether a string is palindrome or not using a Deque through the following algorithm. Step 1. Start traversing string, madam, from left to right. Left side, a character reader at a time. Insert the character in a Deque as normal Deque using insert rear. Repeat step 1, step 2 for all characters of string, this one, madam. And remove one character from the front and one character from the rear end of a Deque using deletion front and deletion rear. We can do it, remove front from this one and status of Deque after removing one character from both the ends. It will happen now. Madam, insert M, and then when from both the end we are deleting, here is also M, here is also M, and then A, D, A. These three characters will be remained there. Front and rear point will be A and A. Now see, match this to removed characters. Step 5, this is match this to removed characters. The characters which are removed, please match it. If they are same, then repeat step 4 and step 5 till Deque is empty or left with only one character. Eventually string is palindrome, else stop, as string is not palindrome. Okay, this is very important part. You people please go through completely, and when there is an algorithm given, I suggest you to just write down this algorithm, the steps in your copy, and after that if there is any example or anything, any program is here, please match them with the particular steps, because at a time you cannot see from here. Take a copy and do it yourself. Okay. And next point, implementation of Deque using Python. Like you, Deque is also an ordered linear list. Like you, Deque is also an ordered linear list. Hence, we use list data type to create Deque in our program. The program should have the following functions or statements defined in it. A statement to create Deque with name myDeque equals to list, same thing. A function insert from this thing. A function insert from myDeque element myDeque.insert 0 an element. As the name implies that. A function insert rear to insert an element at the rear of Deque. Its implementation will be the same as NQUEue of normal queue, requiring 2 parameters, same as insert front. Okay. A function is empty, is checked whether the Deque is empty or not, will be the same as a function with the same name defined for the normal queue. A function deletion rear to delete an element from the rear of the Deque. It only requires the name of Deque and returns the deleted element. We'll use pop without parameters to delete the last element of the Deque. And this is the code snippet, please go through. And a function deletion front to delete an element from the front of Deque also. Its implementation will be the same as DEQUEue of normal queue. A function get front to read the value from the front of Deque without removing it from the queue when the queue is not empty, just like pick, right? And a function get rear to read value from the rear of the Deque without removing it from the Deque. The function accept Deque as argument and returns a copy of value when the queue is not empty, and this thing. Let us write a main function to invoke various Deque functions. Implementation of Deque in Python. Here is a program. You people, please go through this program. If there is any problem or any query, please feel free to ask me. I will clarify the program. It is a lengthy program. Please go through. But easy one. Check one by one. One by one, if you check the output as well as this programming code. Along with this programming code, please check the output. And it is easier if you completely write down the program in your copy and check it thoroughly. Okay. So here we have completed this chapter. I repeat one thing, that this chapter is about queue, right? This is chapter number 4, and we are following the NCERT syllabus for class 12 computer science. And first I will complete the study material. After completion of this theory part, we will go through the practical portion and all about the Python programs for class 12. Okay. And those who are already acquainted with my channel, you people already have done so many programs on Python in class 11 as well as class 12 programs will be also come. You please go through. Okay. So next day we will meet in another class for the next chapter we will discuss. Till then, take care and thank you for watching.